4 o'clock this morning. Crews are still out on the scene. Once again, they're rerouting to Kinsea Road. Then you can hop right back onto 23 southbound. And that's your pinpoint traffic.
Busy morning for you out there. Definitely. You've been hopping on a lot of situations going on in traffic this morning. Well, there are over 1,000 tornadoes that hit the United States every year. You know that. And we are no stranger to that ominous single-tone siren in southeast Michigan and northwest Ohio. They usually form out of a supercell thunderstorm and can flatten an entire town in just minutes. We've seen that devastation. We'll take a look at this. You ever wonder how a tornado actually forms? Well, to figure it out, we came to the Imagination Station, and our favorite scientist, Carl, is here to help us show everyone how a tornado forms. So what do we need to do first, Carl?
Right. Well, the first thing for a tornado is you need an unstable air mass.
Exactly.
You need a thunderstorm, if you will. And we can model that here with some warm, moist air in the bottom of this bucket, of this jug. And we're going to add to the top of it some cold, dry air, really cold air, with some liquid nitrogen.
Okay.
Now, this stuff is 320 degrees below zero. So the temperature differential here is going to be about 500 degrees.
Okay.
Huge. So you might want to step back a little bit. We're going to add this really cold nitrogen in there.
Wow. This would be like the cloud that's created when the two air masses combine and they go straight vertical.
Exactly.
As the warm and cold air meet, the force of their collision creates a spinning vortex, creating a funnel cloud. But it isn't considered a tornado until it actually touches the ground. Now, if a tornado is coming your way, the first thing you might see is a very tall cloud overhead. You might feel the cold gusts of air cutting through the muggy air. The sky may look green, and it will usually start to rain. There's always the chance of lightning and hail as a supercell passes overhead. But if the rain stops abruptly, you might start to see a cloud drop from the bottom of the supercell. This is usually where tornadoes form, and you need to take cover. The enhanced Fujita scale rates the strength of a tornado. So I stood in the hurricane tunnel at Imagination Station to see how strong these winds really are. We started out slow at an EF0 with wind speeds up to about 85 miles per hour. Strong, but not severe. But at an EF1, I am standing in 120 mile per hour winds.
You're up about 105, 120. What? 125 miles per hour. It's getting hard to breathe inside there, isn't it? Hard to breathe. 150 miles per hour. I can't hear you anymore. 157. Isn't that crazy?
And that was considered an EF3. Can you imagine an EF5? This is what happens to neighborhoods when an EF4 or 5 rolls through with winds up to 200 miles per hour. We set up another experiment. This simple pencil is loaded into a tornado gun, and with about 157 mile per hour force behind it, 3, 2, 1. You can see it becomes a projectile and shoots right through this piece of wood. That's pretty cool. Holy cow. Warm air plus cold air plus a whole lot of spinning force equals a deadly combination. And this is the peak of severe weather season right now. We're into it in May. Also, just recently, you all remember the tornadoes from April 25th through April 28th. There were actually 305 tornadoes in that small window of time, and they say that's the most since May of 1955 when they had, a very large outbreak back then. So amazing stuff.
Incredible force.
Stay right there, everybody. We'll find out which lucky NBC 24 viewer won our landscape makeover contest. It's coming up in just a few minutes. Stay right there.